Okay, what I'm going to do is talk you through how to write a conclusion and evaluation using the conclusion and evaluation stuck wall, which you can find on ManageBack. This is a very quick and easy way that you can check that you've got all the right parts when you're going through your conclusion and evaluation. So we'll start with the conclusion checklist. It's really good to start out with a general outline of what you did. So what happened in your experiment? What were you investigating? This is to show someone that hasn't seen anything else other than the conclusion, what you were doing. So you need a very good explanation in there. Now, results including comments on the graph. So if you found something, you have some results to your investigation, so tell us what they are. You can start by talking about the graph. Firstly, is the line a straight line or is it a curve? Did you expect that? It is not what you expected. Can you tell me what the gradient of your graph is, and can you tell me what that means? So you're going to have, when you work out a gradient, changing y over changing x equals the gradient. Now if this has a unit of millimeters, and this has a unit of grams, this shows us the relationship between the two things that we were investigating. So say we were investigating how much mass we put onto a spring and how much that extended the spring. We would be looking into the science of how mass causes extension. This gradient would give us the relationship between those two things. And it could turn out that we need 10 grams to make it extend 10 millimeters, whatever it could be. So we're going to comment on the results. In here as well, you would say if there are any anomalies. So let's think about looking at the graph and thinking, well, which points have gone wrong? Which points don't fit the rest of the data? Which are nowhere near my line of best fit? I want you to talk about those. You pick it out and you say where that might have come from. And that will lead later in your reliability. This is so important. Scientific explanation of what the results mean. So go through and make sure that you're not stating what it means. So you're not just saying if your investigation would be into ice. You're not just saying the ice melted. Anybody can find that information. What we're looking for you to do is show learning that you've taken outside the classroom. Show me that you've done some research. Show me your sources and really explain what this means. You can find a breakdown of all the rubrics inside each classroom, and those will really help you to explain rather than state. Explain whether your hypothesis is correct with comments on the reliability of the data. So this, you would say, I'm going to go back to my hypothesis. What did I say? Was I correct? Can I use my data to show whether I'm correct or not? If you've got loads of anomalies, can you really say that you were right? You don't know if those points are actually true. So you're going to go back and you're going to look at your hypothesis and compare it to the reliability of your data. So if you find that every time you did a repeat that you got a different value for the same measurement, then it's not very reliable. And you might want to pick out a couple of the ones that aren't very reliable. And we'll go into that. But this is your checklist. I want you to read through this and then read through your conclusion and make sure you've got exactly the same type of information. These are all the most important parts. So think about your results. You could use these sentence starters. You could say, my results are. These results, you could fill in a couple, help to prove my hypothesis because. These results may be anomalous because. So we're always looking for this word because that's you explaining. Don't just state, really explain. This is the anomalous result. So this is our line of best fit, and this is my anomaly. Here we see the not so rare anomalous result. You can tell it's anomalous because where we've drawn the line of best fit, this point is nowhere near it. So you would comment on that in your conclusion. Why wouldn't you? You've gone to the trouble of taking all this data, and this one's sticking out. So why not comment on it? And here's our line of best fit. Here I would say that it was linear. It looks like it's going to go through the origin, so I would say it was directly proportional. And I would explain how I know those things. I would say, well, now I can find the gradient. Now, the gradient should be the same at any of these points because it's directly proportional. And all those points lie on the line of best fit. That's very important. Okay. when we're looking at the hypothesis or prediction, you do say something at the beginning of your experiment. We're going to come back, and if you say you are correct, then you need to say how reliable the results you got were. If we look at these results, I predicted that X increases, so does Y. Was I right? Well, I can see that there is a correlation, that they may be increasing, but the data points are nowhere near the line of best fit. There are lots of anomalies, so I can't really use this data to prove whether I'm right or not. Do not worry about if this happens, because that's fine, as long as you can identify that and show me what might have happened to cause that. Okay, the science part. If I had this as my graph, I can see that as the temperature increases, I can dissolve more sugar. Solubility of salt and sugar in temperature. So salt, doesn't matter what happens to the temperature, I can only dissolve that much. But sugar, it does matter about the temperature because this increases. These results show as the temperature increases, we can dissolve more sugar. At 0 degrees, only 175 grams dissolves. But at almost 100, almost 500 grams dissolves. This would be a very good conclusion. There's my conclusion. Then, here's my scientific explanation. So I've got my comments. These results show that. And then I try to explain it underneath. And look, I've got a resource as well, where I've actually gone and looked up this information. And then I would try and explain it even further below. Expanding on our explanation, showing what we know, doing a bit more research is what gets us into the higher levels. Evaluation. This is your evaluation checklist. What was good? There must have been something good that happened. What was bad? What went wrong? Comments on how things went wrong and how this may have affected your results. This is very important. Someone's going to read this and they may want to do the same experiment as you. Can you please tell them what went well? They'll do that again. What went badly? They'll be able to improve on it because you're going to give them how you would improve it. So what went well? Do not write, my method is written in steps. I did everything for my method. I had fun. This does not comment on the results. You should write what went well as what was good about how you found the experiment and how it gave you good results. That's what we're looking for. Good things to say. My method compensated for the extra water in the beaker by saying to clean it out first. This means that my results might be valid. I'm showing how something I did would have impacted well on the results that I got. And there's a couple of others here that you could use. Next, what went badly? So, you should aim to identify weaknesses in the accuracy and reliability. If you click on these words, they will tell you what they mean. Also, there is another video on ish physics about reliability and validity of your method. For example, due to reaction time, it was not possible to start, stop the stopwatch at exactly the beginning and end of inclined plane for the motion of the ball. How did that affect your results? Well, if I can't react that quickly and I'm trying to stop it all the time, I'm actually going to add a bit too much time onto my results every time. How might that have affected them? And look, remember to look for control variables in your method. So that might have actually been one of my controls, and I couldn't control it. So that might affect the validity of my results. Improvements. If you say something went wrong, you've got to give a person an improvement to it. So what do you think you should do? Next time, we could use light gates. Light gates, actually, when the ball goes through them, they cut a beam of light and they stop automatically. There is no human error, there is no human reaction, they stop automatically. No reaction time is involved. This would mean that the results would be more reliable as they don't have our reaction time added into them. Notice I take the weakness, I explain how it affected the results, and then I take the improvement, explain how it improved the results. That's your steps to go through. These are your keywords, and you can click on any of the keywords that you see underlined in any of the PowerPoint slides, and it will take you to an explanation about them. Or you can go and look on this video. Okay, that's your basic conclusion and evaluation. You can go into any of the science rooms, A105, A106, and you can find out a bit more about the rubrics there. Okay, good.